Okay, so PurpleTeam is a security regression testing CLI in SaaS, targeting web applications and APIs. The CLI is specifically targeted at sitting within your build pipelines, but can also be run manually. The SaaS that does the security testing of your applications and or APIs can be deployed pretty much anywhere. So I'm going to briefly talk through the journey. So as John mentioned, it's been a bit of a labour of love. It's been 3.8 years to date. That's brought PurpleTeam from a proof of concept to where it is now. So I finished off writing the first 2 books of a book series to help developers upskill their security. This is called Holistic InfoSec for Web Developers. It's available to read for free online. And I ran lots of workshops with the proof of concept to elicit developer feedback and confirm that what I wrote about was actually true. Most of the time it's been 7 days a week and most of the time 2 full-time jobs. Building a tool that helps developers write secure code is a great way to learn about security. If you want to learn more about information security as a developer, we'll assign a mentor to you and you can help yourself and the community by building out PurpleTeam with us. So this is a high-level overview of the architecture of PurpleTeam. So we've got the CLI here, we've got the system under test, that'll be your system under test. And in the back end, we've got a few components here. We've got the orchestrator, which is pretty much responsible for looking after the actual testers. The testers are, currently we've got an app scanner, we've got a TLS scanner, the server scanner is yet to be implemented. We'll probably be using Nikto for that. The TLS scanner uses test SSL.sh as an embedded emissary. So that actually sits within our TLS scanner container. We've got some external emissaries here, Zap and Selenium. So they sit out in their own separate containers. And N number of those are spun up depending on what's in the job file sent from the CLI. So we've got real-time comms that come back from the testers. So they're pushed to Redis channels. The orchestrator picks those up and pushes them back to the CLI are using server-sent events or long polling requests from the CLI, depending on what you select in the orchestrator config. We've got SAM CLI, which hosts our Lambda functions. The Lambda functions spin up the stage 2 containers here. So that's a very quick sort of overview of what the architecture actually looks like. So how does PurpleTeam help us as developers? How does PurpleTeam help us as a business that creates software? And why would I want PurpleTeam in my build pipelines? To answer these questions, I'm going to take you back to a section that's in a number of my previous talks. Traditionally, how have we found bugs in software that we write? So basically, we haven't really, or we've done it really late. So our red team has a week or 2 to find all the defects we've been conscientiously adding for months. So this red teaming exercise is approximately $20,000 per week for a 2-week engagement, generally for a small to medium-sized web application. That web application is approximately 6 months to develop. So that's approximately $40,000 per 6 months per project for the red teaming exercise. Generally, 5 criticals, 10 highs, 10 mediums, 10 low severity bugs will be found, and many bugs left unfound waiting to be exploited. So the business decides to only fix the 5 criticals because they're now so expensive to fix, because they now cost 15 plus times what they would have cost to find and fixed if they were found and fixed as they were introduced. So that's 5 bugs times 15 times $320, which is approximately, say, 2 developer hours equals $24,000 to fix those 5 bugs. So the bottom line is this is a 6-month project and we've got a 2-week red teaming engagement, which is going to cost us $40,000, and only 5 red team bugs are going to be fixed, which costs us $24,000. So this is too expensive, it's too late, and too many bugs are left unfixed because it's so late in the SDLC, and each bug now costs 15 plus times what it would have cost if they were found and fixed as they were introduced. Instead of deferring the finding and fixing of security defects to a traditional red teaming exercise, PurpleTeam helps us find and fix our defects as we're creating them. But how, you might ask? So PurpleTeam runs against our web apps as we're creating them, informing us of the security defects we're introducing in close to real time. So now we know we need PurpleTeam. So how do we set it up? So I'm just going to show you the documentation page. Soon we're going to run through a full system run. Okay, so we've got a few things here to set up, and they're all in the docs here. Okay, so this is at purpleteam-labs.com/doc, and you'll be able to find all this. So we need to set up a Docker network. You can set it up manually, or you can just run the npm run commands, which basically runs a Docker, a compose file underneath, and that'll set up your a Docker network for you. You need to set up a system under test. We usually use NodeGoat for a lot of our stuff. We use the PurpleTeam infrastructure as code SUT project as well. So this is quite useful for setting up any web applications, deploying them, as long as you've got the source code for them, obviously. And a little bit of config there for NodeGoat to apply to get it ready for us to actually start using it as a system under test. So our Lambda functions, stage 2 containers, I've got links here to the actual readmes, which have got the setup details for these two main sort of component areas. So Lambda functions, there's 3 of those, and our stage 2 containers, which I briefly showed you before for Zap and Selenium. For the orchestrator, we've got a little bit of work to do there. I've got some firewall rules to set up. We need to make sure host IP forwarding is turned on. And our testers, app scanner, TLS scanner, and server scanner. As I mentioned, the server scanner is yet to be implemented, but it's not far off. So we've got, again, the application scanner README, link to it there. Same for the TLS scanner. And that basically has got some details there which shows you how to set up those components. And same with the PurpleTeam CLI. Okay, so the CLI install options, there's 3 main options there. Clone the Git repository, npm install locally or npm install globally. So the npm install locally is a pretty good option if your build pipeline is predominantly written in JavaScript, Node.js. And there's some there's some code here which leads to another repository, which basically shows you how to embed the PurpleTeam CLI into your build pipeline and run it from a JavaScript-based build pipeline. You've got the npm install globally option, which is a good option if your build pipelines are written in other languages. So what this allows you to do, basically it gives you a system-wide command that you can launch from anywhere on your system. npm link's also another pretty good option, which allows you to clone or fork the CLI repository and just set up PurpleTeam as a system-wide command, again, based off the actual repository. Locally, yep. And the CLI workflows. So basically we've got the same sort of a clone repository, npm install locally, npm install globally, listed here, here, and here. And under there, we've got the actual running details for how you go about running the CLI. I won't dive into that due to time constraints. We don't really have much time for that. But it's all on the README file there. The full system run is docs. Again, so under the workflow section, full system run here. It's got 5 steps there, which we're going to be showing you soon in a video. Yeah, so I probably shouldn't spend too much time actually walking through these, but they're here anyway. So, so if you want to spin it up, you're probably going to need to work through these 5 steps. Emulating the AWS Lambda service. So the idea here is using SAM CLI. So we've got to spin up SAM CLI in order to host our Lambda functions locally. These are the Lambda functions that provision the stage 2 containers. So we've got provision app emissaries, that's for Zap proxy, provision Selenium standalones for Selenium, and a single Lambda here for actually bringing down those S2 containers once the application tester has finished. For debugging, we've got a section here which basically helps you debug all the components in the back end and or the front end. So all that docs there, if and when you need it. So I've got a video to show you now which actually works through the entire running of PurpleTeam CLI. So can we run that now?
Hi, today I'm going to show you a test run with the back-end components as well. I'm starting Docker stats to show you which containers are coming and going. We start Docker Compose UI, which is responsible for taking orders from our Lambda functions to start and stop the stage 2 containers. We start SAM local, which is responsible for hosting our Lambda functions locally. And we already have our system under test running. Now once we've built our stage 2 images with npm run dc-build, we can bring them up with npm run dc-up. And then we start the CLI. In the bottom left terminal, you can see the validated, filtered and sanitized job file contents. In the top right terminal, Docker stats is showing us the stage 2 containers being brought up. In the bottom left terminal, we're checking and retrying that the stage 2 containers have come up and are responsive. All testers are now running. As the test run progresses, in the CLI tester complete panel, that's the donut meters, you will see the percentages progress. These are total percentages per tester. In the running statistics panel, just to the right of the donut meters, each row represents a test session as defined in the job file. Here I'm tailing the CLI TLS tester log just to save right arrowing on the CLI terminal to the TLS tester screen and not being able to also see the app tester progress. Back to the running statistics panel. The thresholds you see are also defined in the job file as alert thresholds. A given test session will be considered a fail if the bug count exceeds the alert threshold. Alert thresholds are useful for brownfields projects where you have existing defects but still want a test to pass. These are the definitions. You may find yourself referring to these quite often. Back to the running statistics panel. You'll notice a complete column. These cells represent percentage complete of the test session, where you may have more than one of these for a given tester. In order to initiate a test run, the build user needs to define and supply a job file. This is the documentation that will help explain the schema and help you construct your job file. Next, I'll show you some example job files. This job file is very similar to the one we're using for this test run, except we're targeting nodegoat.sut.purpleteam-labs.com, which is deployed using the PurpleTeam infrastructure as code system under test project. The new bugs panel of the CLI shows bugs over and above any specified alert thresholds. If this count is above 0, then you are going to have at least one failed test session. The total tester progress meter to the right of new bugs shows the combined progress of all testers. These logs I'm showing you are the raw CLI logs taken from the current finished test run. This particular log is from the low priv user test session of the current test run, currently being written to the top of the two CLI window panes as we speak. You'll notice that this particular test session is only testing a single route, the profile route of our system under test. This particular log is from the admin user test session of the current test run, currently being written to the bottom of the two CLI window panes as we speak. This test session is testing two of our system under test routes, the profile route followed by the memos route. As you can see, the server tester is currently inactive. Now we're looking at the TLS tester log. There's only ever one of these per test run. You'll notice the color codes in amongst the text. These are used to display the log text in color. We'll see how this works soon. We're looking at the same CLI logs as before. Tools such as cat, less and tail, if configured correctly, will render the color codes. Just reiterating that these CLI logs are currently being written. I've just taken them from the finished test run. This is the low priv user test session CLI log from the application tester. As you can see, this is a failed test session. This is the one and only TLS scanner test session CLI log that I showed you before, but with the color codes rendered. These CLI logs are what is printed to the CLI terminal if you are running it in CUI mode versus no UI mode. Right arrowing and left arrowing in the CLI terminal will switch between the different tester windows. As you can see, this is a failed test session. When you see the outcomes have been downloaded to message, that means the test run is complete and you can now inspect the report files generated by the emissaries and the result files generated by Cucumber. This is what the outcomes archive looks like once it's been packed by the orchestrator and sent to the CLI. You'll notice the report and result files. This is the HTML report file generated by the application emissary, Zap Proxy, for the low priv user app scanner test session. It lists the alerts or defects, along with how they were found, how you can reproduce them, as well as directions for fixing them. This is the HTML report file generated by the application emissary for the admin user app scanner test session. This is the HTML report file generated by the TLS emissary, testSSL.sh, for the one and only TLS scanner test session. This is the markdown report file generated by the application emissary for the low priv user App Scanner test session. This is the Markdown report file generated by the application emissary for the admin user App Scanner test session. This is the CSV report file generated by the TLS emissary for the one and only TLS scanner test session. Here I'm highlighting the severity levels. These can be one of low, medium, high or critical. Refer to the job file documentation for further details on these. This is the JSON report file generated by the TLS emissary for the one and only TLS scanner test session. These are the three MD-JSON result files generated by Cucumber for the three test sessions. Low-Priv user App Scanner test session, admin user App Scanner test session, and the one and only TLS scanner test session. The App Scanner admin user test session for the profile route has completed. It's now starting on the memos route. The App Scanner low-priv user test session for the single profile route has finished. The log which has just scrolled off the screen provides defect counts and details of where to look in the reports. This is the log and outcomes files documentation. The App Scanner admin user test session for the memos route has completed, which means the test session it's in is finished. In this case, both low-priv user and admin user test sessions have failed. The CLI log file that I showed earlier contains details of how to use the report files to locate and remediate the defects. You'll also notice that the stage 2 containers have been brought down. Now we've just right arrowed to the TLS tester to watch it finish.
All right, Kim, it looks like our video is ended. You can go ahead and pick up on your share, and we've got a couple more minutes to go over your
Cool.
closing.
Coolio. Cool. So yeah, we're looking for contributors to help build PurpleTeam out if you're interested. If you don't have huge amounts of skill in programming and that sort of thing, and you have some other skills, or are you quite junior, then we're still keen on getting your hands on keyboards to help us out. And yeah, so that's pretty much OWASP PurpleTeam in a nutshell. There's a Twitter link for you to follow or do whatever you want to do with, and that's PurpleTeam.